Hello students, today we are going to have a discussion on air pollution control. We know that air pollutants are mainly classified into two based on the size of the particles. The first one is particulate matter, which is having particle size greater than 1 micrometer, and the other one is gaseous pollutants, which have size usually less than 1 micrometer. So, we will be seeing how to control these two types of pollutants separately. So, the control methods that are used for particulate matter mainly include gravitational settling chamber, cyclone separators, fabric filters, electrostatic precipitators, and wet scrubbers. First, we'll see gravitational settling chamber. This method is mainly used for the removal of particles which have size greater than 50 micrometer. This method is less efficient for very small particles. It requires simple maintenance and usually is used as pre-cleaners prior to passing through high efficiency collection devices. So as you can see from the figure, the gas stream is allowed to flow through the gas inlet at a low velocity, allowing sufficient time for the particles to settle through the dust hoppers. And the clear air passes along the gravitational chamber through the gas outlets. Forward settling chamber is a modification over the gravitational settling chamber. In this chamber, there are several trays arranged parallel to each other, one over the other. The gas laden with particles enters the gas inlet and moves between the trays and gets settled on the trays. And the clear gas comes out through the gas outlet. The collecting efficiency is more for this method. The flow velocity in the chamber remains substantially the same, and yet each particle has to travel a shorter distance to fall before reaching the bottom of the passage between the trays. The next method for the separation of particulate matter is cyclone separator. This method utilizes the centrifugal forces generated by the spinning gas stream to separate the particulate matter from the gas stream. That is, when this gas is introduced inside the cyclone separator, it will be subjected to centrifugal force. And the centrifugal force is much greater than the gravitational force exerted on the particles. This method is more effective in removal of smaller particles, and it requires less space to handle same amount of gas as compared to the gravitational settling chamber. The cyclone separator consists of a vertical cylinder with conical bottom. It is fitted with a tangential inlet located near the top and an outlet at the bottom of the cone for discharging the separated particles. The gas outlet pipe is extended into the cylinder to prevent the short circuiting of gas from the inlet to outlet. The particle laden gas, as it enters the cyclone cylinder, it receives a rotational motion. The vortex so formed develops a centrifugal force which acts to throw the particles radially outwards. The gas spirals downwards to the bottom of the cone, and at the bottom the gas flow reverses to form an inner vortex which leaves through the outlet pipe at the top. The next method of removal of particulate matter from a gaseous stream is by using filters. The filter uses the following mechanism to remove the particulate matter, that is inertial impaction, direct interception, and diffusion. Inertial impaction occurs when the particles with high inertia follow a fluid streamline, but as it approaches the fiber, its trajectory departs from the fluid streamline around the fiber. The departure of the particle from the streamline may be sufficient to allow the particle to deposit on the curved surface. In direct interception, the particles have less inertia and almost follow the streamlines around the obstruction. The particles clear the obstruction, but their outer peripheries come in contact with the fiber. Diffusion mechanism is important for particles that are in the submicron range, that is usually 0.01 to 0.05 micrometer. The particles usually do not follow the gas streamline surrounding the fiber because the individual motion of the particles can be affected by their collisions with the gas molecules. This zigzag random Brownian motion causes the particles to impinge and adhere to the surface of the fiber. Fabric filters are the most commonly used filters in industries. In this, the open spaces in the woven fabric are many times the size of the individual particles. And the collection efficiency in the initial stages, it will be poor, but in a short time, the captured particles itself form a bridge across the cloth opening and the particle layer is formed, which improves the collection efficiency, that is up to 99.99%. The periodic mechanical cleaning is required to maintain the efficiency. A fabric filter system, that is a bag house, is an example for the fabric filter. It consists of tubular bags suspended from a shaker mechanism, as you can see from the figure. Particles fall into the hopper when dislodged from the fabric and it comes out through the dust outlet. The structure in which the bag hangs is called as the bag house. The particles enter, pass through the fabric and the particles are deposited inside the bag. Cleaning is done by shaking at fixed interval of time. Hoppers are provided for dust collection. The next method used for the separation of particles from a gas stream is electrostatic precipitator. This system consists of a positively charged collecting surface and a high voltage discharge electrode wire suspended from an insulator at the top and held in position by a weight at the bottom, as you can see in the figure. At a very high DC voltage, a corona discharge occurs close to the negative electrode, setting up an electric field between the emitter and the grounded surface. The particle-laden gas enters near the bottom and flows upwards. The gas close to the negative electrode is thus ionized upon passing through the corona. As the negative ions and the electrons migrate towards the grounded surface, they in turn charge the passing particles also. The electrostatic field then draws the particles to the collector surface where they are deposited. Periodically, the collected particles must be removed from the collecting surface. This is done by vibrating the collector to dislodge the particles. Another method used for the control of particulate matter is using wet scrubbers. Wet precipitation is the principal mechanism used in wet scrubbers. That is, it is similar to the removal of particulate matter from the atmosphere by precipitation, that is rain. Wet collectors have number of advantages over dry collectors, like simultaneous removal of both particulate matter and gaseous pollutants. But the disadvantage of using wet collectors is the problem of corrosion and disposal of liquid waste. The basic function of a wet scrubber is to provide contact between the scrubbing liquid, that is water, and the particulate matter. Collection mechanisms are impaction, interception, and diffusion. The commonly used wet scrubbers are spray towers, centrifugal scrubbers, packed bed scrubbers, plate column scrubbers, and Venturi scrubbers. Spray tower is the simplest type of wet scrubber. In this, the water is introduced by means of spray nozzles as shown in the figure. The polluted gas flows upwards and the particle collection results because of inertial impaction and interceptions on the droplets. The maximum collection efficiency by inertial impaction is independent of the particle size. Centrifugal scrubbers are another type of wet scrubbers which are used mainly to increase the collection efficiency of particles which are very small. In this type of scrubber, the polluted gas is introduced tangentially into the lower portion of the vertical cylinder. Water droplets are injected into the flow stream from the sprays directed outwards from a central manifold. These droplets are caught in the spinning gas stream and are thrown upward towards the wall by centrifugal force. During their motion, droplets collide with the particles and capture them. The scrubbing liquid along with the particles flows down the wall to the bottom of the scrubber. The clean gas exits through a demister and is processed for the removal of any entrained water droplets. Packed bed tower is another type of wet scrubber which is commonly used in industries. This consists of a tower which is packed with a material such as coke or broken stone. The polluted gas stream moves upwards and passes through the packing media and comes in contact with the scrubbing liquid stream, which is moving downwards over the packing in a film. The spent liquor that is collected moves downwards, whereas the clean gas comes out of the tower. Another method similar to the packed bed tower is baffle plate scrubber. In this method, the gas stream is passed through a flooded perforated plate for scrubbing. The impingement baffles are situated directly above each perforation onto which the gas jet is impinged. The particles are collected by inertial impaction. Venturi scrubbers offer high performance collection of fine particles, usually smaller than 2 to 3 micrometer in diameter. They are particularly suitable when the particulate matter is sticky, flammable or highly corrosive. The high performance of the Venturi scrubber is achieved by accelerating the gas stream to very high velocity, that is 60 to 120 meter per second. The high speed action atomizes the feed liquid that is generally introduced in a uniform fashion across the throat through several low pressure spray nozzles directed radially inwards. The droplets accelerate in the throat section, and due to velocity difference between the particles and the droplets, the particles are impacted against the slow moving droplets. This acceleration of the droplets is not likely to be completed in the end of the throat, so the particle collection continues to some extent into the diverging section of the Venturi. The gas liquid mixture is then directed to the separate device like Cyclone Separator, where the droplets carrying the particulate matter are separated from the gas stream. Till now, we have seen the various methods of controlling the particulate matter. Now, the methods used for controlling the gaseous pollutants are mainly absorption by liquids, adsorption onto solids, and combustion methods. The combustion methods mainly include steam injection type, thermal incinerator type, and catalytic combustion. First, absorption by liquids. It involves transfer of pollutants from gas phase to the liquid phase. A proper scrubbing medium with below properties is desirable. That is, the medium should be having low vapor pressure, non-corrosiveness, easy regeneration and recovery, low cost, low viscosity, non-toxicity, non-flammability, and chemical stability. Packed tower, tray, or plate tower Venturi scrubbers are some of the gas absorption equipments. Next method of removal of gaseous pollutants is by adsorption onto solids. As we know that adsorption is a surface phenomenon by which gas or liquid molecules are captured by and adhered to the surface of a solid adsorbent. The attractive forces holding the molecules on the surface may be either physical, known as physical adsorption, or chemical, known as chemiadsorption. In physical adsorption, the gaseous material condenses upon the surface of the solid. The adsorbed material may be removed or desorbed by reducing the pressure or by increasing the temperature. It is a reversible process. But in case of a chemiadsorption, it is resulted due to the chemical interaction between the solid and the adsorbed material. It is usually irreversible. The molecules are held to the solid surface by chemical bonds. The adsorption method is mainly used where there is requirement of control of order. The material that is commonly used as adsorbent are mainly activated carbon, activated alumina, silica gel, etc. In the adsorption process, the first stage is the diffusion of the pollutant from the bulk gas phase to the external surface of the solid. The second stage is the diffusion of the gas molecules into the pores of the solid. And the third stage is the actual adsorption on the active sites inside the pores. Combustion. Many industrial processes which produce gas streams have no recovery value. So, absorption or adsorption methods may not be economically feasible. This method causes the destruction of odors, toxic substances, and reactive materials. It prevents explosion hazards and reduction of pollutants in the oxidized form. The products of combustion are odorless, colorless, and harmless, giving off carbon dioxide and water vapor. When the pollutant is destroyed, the combustion must be complete. Otherwise, intermediate products of combustion will form, which may be noxious than the original contaminant. The common methods that are used in combustion are direct combustion or flaring, thermal incineration, and catalytic oxidation. Direct combustion or flaring. Highly combustible streams with high heating values can be eliminated by direct flaring. Flaring is not a satisfactory solution when the gas stream contains excessive amount of inorganic pollutants like sulfur, chlorine, fluorine, etc. The figure shows a steam injection type flare. In such a design, it incorporates steam injection through jets surrounding the flare tip. The steam jets induce turbulence in the periphery of the flame and add heat to the combustion process. In addition, this sets up a water-gas reaction giving carbon monoxide and hydrogen, which help to generate smokeless flame. A pilot flame is also provided to reignite the gas stream if flameout occurs. Thermal incineration is the most efficient as well as the most flexible technique used for destroying diluted gas streams. In thermal incinerator, the waste gas is preheated often over an auxiliary fuel-fired burner, and is passed into a combustion chamber where a temperature of 500 to 800 degrees Celsius is maintained. The gas stream is kept at this elevated temperature long enough to allow complete combustion. The gas stream is introduced in such a geometry and at a velocity that promote turbulence and thorough mixing of the fuel. This type of incinerators require little maintenance. Catalytic combustion. This method is usually used when thermal incineration of diluted pollutants is not economically feasible due to additional fuel cost, or when the heat recovery only provides marginal saving. The combustion process takes place in a catalyst, usually at temperature several degrees below the required for thermal incineration. The different types of catalysts that are usually used are precious metals like platinum and palladium or their alloys. The catalyst is coated with suitable elements like metal ribbon or ceramic rods or alumina pellets. This method consists of a reaction vessel in which the catalyst is arranged in a single or multiple fixed bed. There is a preheat section where the gas stream is heated to the temperature required to support catalytic combustion. The preheated gas is then passed through the catalytic bed where the combustion occurs. To maintain the catalyst in an active state and to achieve complete combustion, about 1% excess oxygen is required. So that's all about the different types of control methods used for particulate matter as well as gaseous pollutants. Thank you.